Hi everyone. I want to thank you all for your feedback on the Connect Shake Table videos I put out. I was really surprised by how many views I got, especially on the short that I created. And I wanted to provide a little video to show kind of the inner workings of the shake table, how it works. So let me show that. So as you can see, I've deconstructed the shake table down to its essential components. Right here I have the tower. And over here to the right, I have the gearbox. Here's the cart right here. And then here is the track component. And then finally, just the end piece. So let me walk through and show how these go together. So this here is the cart and the track. The track was built specifically such that the wheels of the cart will line up perfectly. So here's the cart design. The instructions, full step-by-step instructions are at a link in the description, but here's just some general overall shots. This is the part that connects to the gearbox that allows the cart to go back and forth. And so I'll show how you can slide it right in. Oops, I knocked over the tower. Ignore that noise. It's kind of hard to do while videotaping. There we go, it slides right in, and it took me a while to figure out exactly how to make it line up perfectly here, but you can see there's like very little gap at all. I was kind of surprised that I was even able to find a configuration that worked. So also you can see that each of these sections is just repeating, so it's very modular. You could make it longer if you wanted to, but that's the cart and the track. Next, there's just the end piece. This part's pretty simple. This just connects in right here. It snaps in at all of these spots. So I'll quickly just connect that and then show what it looks like. So there's what it looks like with the end piece connected. Technically, well, it does block the cart from going any further. But it's still free on this end. So we gotta add the gearbox. So here's the gearbox. So again, you have this rod that sticks out here. This is where you attach the drill. This is the low gear side. So you have a small gear going to these large yellow ones. And it has all these 4 sets so that it can handle the torque of the drill. These are also friction locking gears, which means that hypothetically, if you really had a very strong drill attached to this, the friction would give out between the rod and these gears before all these inner components would break. And then on the other side, you have the lower gear setting. So you can see another set of gray gears there with a rod sticking out to attach the drill. So this is a higher gear setting, and this is where you can get the much higher frequencies of the shake table. And then right here, this is the part that actually makes it go back and forth. So it's offset here using these connectors. It's a little bit tricky to get this configuration. This is also the part in the shake table that's most likely to break. I've had to replace these rods a few times just because you get so much back and forth that it starts to cause fatigue failure. I don't know if it's doing it yet, but like right there between that spacer and the connector, it often builds up some stress. So something to watch out for if you build one yourself. And then these rods right here, these just attach over here to the cart on these connectors. So you can connect those. Well, it's kind of hard to do it when I'm holding it. So I'm just going to show what it's like connected and then move on to the next part. So there we go. We have the full shake table constructed. So you'll see it's connected here. So this reciprocating arm then moves the cart back and forth within the track. So if I turn this rod here, you'll see how it moves it back and forth. Just generally does like a sinusoidal sort of motion because it's tracing a circle right there. So, and then if I go to the other side here, turn this one it's going to do it much faster. The other nice thing about this table is that it's very easy to transport. So you can grab this corner right here, lift it up, you can carry it just one finger. It also stores vertically, so you can stash it in like a storage closet or something like that between activities. So very easy to use, very easy to move around. You can also pick it up from the other side here too. Works just the same. So that's the table, and let's talk about the tower. So here's the tower. It's pretty simple construction. The base is the only thing that's different. I added these connectors here, these rods, just for extra rigidity. And when you attach it to the table, it's attached with these little green rods down here. Once you attach to the table, you can take off this gray rod and it'll act more like a pinned base, but with the gray rod attached, it's more like a fixed base. And then at each level you have snapped in, you have these masses that are at the middle of each floor. These can easily be taken off. And then you can have a massless section, so you can have a very light building. These are very simple construction, only takes a few pieces. And then I just have these washers with, I think it's a 1/4 inch center diameter. You can just pick these up at like a hardware store. They're pretty cheap. So you can just repeat that every floor. You can change the number of masses. For here I have a total of 8 washers, which is decently hefty, especially considering the NEX. And yeah, so let me put this back here. The other nice thing is you can slide these around. So if you want to have all the mass on one side, you can do that and show what it's like if you have the building mass only on one side. Again, this is just one way that you can build a building on this. You can build whatever you want, really. But this does provide a lot of flexibility because you can create each floor. The size between this, the diagonal, is 2 red rods long. So if you know connects, it's these ones right here, and then you use an orange connector in the middle. Yeah, and then you have these kind of out of plane bracing right here. This prevents it from tipping over in the out of plane direction. And yeah, I found that it's pretty robust. It doesn't easily collapse, so it makes for pretty safe demonstrations. And I'll show you how to put it onto the table. So here it is. All you do, it's difficult to do with one hand. I can't do it with one hand actually, but you just connect the green rod in to those spots. It's best to do it in the 2 center ones. The cart does have a bunch of different spots you can apply it to, but having it in the center means that it's going to distribute the forces more evenly on the shake table. So that's what I'll do. And there you have it. The tower is connected to the cart of the shake table right there. As I mentioned before, if you take these off, then what you get is you get like a pinned based configuration. So you can see it's much looser at the bottom now. Typically I like to do a fixed base. Pinned base almost always leads to soft story effects. So, and yeah, if you're really using a stiff building on this and the table's shaking a lot, you can also weigh down the ends with like textbooks. So for example, I could put my good old Dynamics of Structures textbook there. Let's do over here, Fundamentals of Structural Analysis. Maybe we can do on top of that, of course, some finite element method. Let's do some calculus on this side. So now, this is another way that you can both show kind of how much force is being exerted, and it can prevent the table from moving around a lot. And that's the other dual purpose of these end pieces and kind of gearbox area, is to weigh it down. So if you don't want people to be having to push down on the table, you can do that. So yeah, there's a little bit of explanation as to all the parts of the shake table and how they're put together. Yeah, if you have any questions, or if you want to build one yourself and you're having some difficulty, just let me know. Ask any questions about how it goes together, how it works. And I hope that this can be a tool that educators can use to teach really complicated engineering topics in a way that's just fun and in a way that anyone can understand intuitively. That's my passion. That's what I like to do. So if you like that sort of content, feel free to leave a like, leave a comment, and subscribe.